Hello, welcome to another episode of SaaS Scaled. I'm pleased to be with Devvret Rishi here, coming from Predibase, and we are going to talk about AI. We are talking about LLM and a number of other topics here. Dev, welcome to the conversation.
Thanks very much, Armand, for having me. Excited for it.
Can you tell us a little bit about yourself and the story behind you starting the company? You are the CEO and founder of the company and co-founder of the company. So it's good to hear from from your side. How do you see it? What was the story? You did some probably AI related work before you join and start the company, and then how did you decide that this is really what you wanted to do?
Definitely. Yeah, my background has been in AI for some time now, over a decade. I started off actually studying it, doing computer science and statistics with a master's in CS focused in machine learning. And then I like to say that I sold out and became a product manager at Google and spent time as a PM across a number of different teams at Google, mostly seeing how machine learning got productionized into the product. I saw both how Google Research productionized machine learning into products like the Google Assistant or Google Search, and then spent a fair amount of time on Vertex AI, which is GCP's machine learning platform, where we were trying to help organizations actually adopt ML into their products and any of the Google Cloud customers be able to do a lot better. While I was there, I was also the first PM for Kaggle, which is a data science and machine learning community Google had acquired in 2017, actually. When I joined, the community was just about 1 million users, which to me was fascinating. I didn't know that there were 1 million people who could do data science work or knew pandas and all the other libraries. But one of the things that was really eye-opening to me was over the time that I was there, the community 5x from 1 million to over 5 million users. And today it's about 14 million users.
Oh, wow.
And so I think that has just spoken to the growth in the level of interest, as well as the amount that machine learning has now started to permeate any technical user's toolkit. And so I got really passionate about seeing that growth, but also the reality of how much organizations were struggling to be able to adopt machine learning while at GCP and Vertex AI. So in 2020, I met my other co-founders, Piero, Travis, and Chris. And really at the time, Piero had an idea for how to make machine learning more accessible based on top of an open source project he had built while he was at Uber, just to make his life easier. So we all got excited about that idea in 2020, and we started the company at the beginning of 2021. And we've been working to make machine learning a lot easier for any developer out there since.
Fantastic. So even if it sounds like some years, but in this technology, I think that moves so fast, it's much longer term. I think you have seen it from the very beginning to where we are today. Now, just to just to start, I would like for you to bring us up to speed from your perspective. What are the generations of this kind of creating these data models, training the model, building the data models? During the last maybe 5-10 years that you have seen, probably we have moved from some generation to another generation. I think we are now at the point that people talk about Gen AI and MLL
Yes.
very often. So these kind of abbreviations were not that commonly heard just a year ago, and now you hear everywhere this kind of LLM and OpenAI and AI in general being discussed very often.
Yeah, no, it's a great question. If I were to break down the generations of modeling, I'd actually go back even further than 10 years and probably say, Gen Zero, I think of like the 80s and the 90s was like really machine learning in the lab. So people had proven out that, this concept of a multi-layer perceptron, or, what originally became a neural network, was an interesting phenomenon in theory and in research. But most machine learning wasn't really feeding production applications. It was feeding financial models and, theoretical papers, really. And that's where I see Gen Zero machine learning as ML in the lab. Then I think the late 2000s and early 2010s, so like right about a decade ago, have really been about what I would consider simple tabular models. So this was the idea of like, linear regression and then tree models, XGBoost, CapBoost being kind of the dominant ways to do machine learning. And by the way, we saw this completely on Kaggle as well. If you went to any Kaggle competition in 2012, 2013, 2014, the winning and dominant algorithm was XGBoost and eventually LightGBM, which is just another, gradient boosting tree framework. But the key idea here was like, more or less what everyone was doing was just the exact same formula. They were taking these models and then they were training them all the way from scratch, running some hyperparameter search, and then trying to do clever feature engineering on tabular data in particular. And so that's really where you started to require more and more data science expertise, because how do you mess with these hyperparameters? How do you do the feature engineering was like the domain of these more experts. And it's what I call AutoML V1, providers like maybe Data Robot or Google AutoML that I worked on tried to replace in a large way. But I think the most interesting generation of AI has actually been Gen 2, which I would actually argue started in 2016 and has doubled down in a large way with the LLM wave. And the way that I see the Gen 2 is really the deep learning generation of AI. And with deep learning, it was really about having, not just having to train every single model from scratch, but taking these really powerful pre-trained models, starting with something like a BERT model, for example, that came out of Google, but taking these pre-trained models that had some prior knowledge and now could be applied to your tasks and then fine-tuned. And so, this, I think, wave enabled a whole new set of capabilities. You no longer had simple formulas that, defined what AI was. You actually had the ability to work with text and images and do things that actually felt a little bit more like AI, like building basic chatbots. And what we've seen with LLMs is actually just an explosion of this deep learning generation of AI. And the explosion has been driven by going an order of magnitude or 2 orders of magnitude larger. So BERT large was 375 million parameters. Now we see the smaller end of large language models be something like 7 billion parameters, and the larger end be something like hundreds of billions. And what we've really seen is you take that same principle and concept, and you're able to unlock a set of new use cases overall. And so that's where I kind of think about, the generations of machine learning. And, one thing we like to say is the future is fine-tuned. It's what I'm wearing on a shirt right now even. And the main reason for that is because it's this deep learning generation with fine-tuning on top of it.
Yeah, fantastic. And then when it comes to any of software applications and technologies, we know at one point coders start coding it, and then it gets democratized. It's coming to power users, and even sometimes that ability may come to the hand of end users. And that's a more kind of low code, no code, and self-service revolution that's happening everywhere in any category of any software that you see at the beginning comes at the very technical level. Have you seen that kind of movement as well with regard to, LLM and AI and these kind of things, probably at a faster pace? And what's your take on it?
Yeah, the first thing I want to say is this movement, I think, is critically important. Like, I think technologies become interesting when they become put in the hands of the average software developer. So, I think one of the most fundamental shifts that happened in the last 2 decades was the shift to cloud. And when that actually became useful was when like your average software engineer could spin up something in AWS. We lived in a whole new world, and it led to this proliferation of SaaS applications overall. So, the high level context I want to say for your question is I think it's a very important trend. But to answer it directly on are we seeing it in AI, I would say it's a 2-part answer. And the first part of the answer is we see a lot of interest. But the second part of that answer is I don't think we've seen yet that interest materialize into successful production applications. So we actually at Predibase, we surveyed 150 executives, data scientists, and developers across 29 countries, across a set of many different organizations. And there was something really interesting there that I found, which was 85% of organizations said that they were either actively using LLMs or had immediate plans to do so. It was on their immediate upcoming roadmap. So 85% of organizations, not just tech companies, but healthcare, financial services, said that they were directly interested in these, directly interested in this activity. But today, only 13% of those organizations said they had an LLM application running in production. And so I think where we are as an industry today is a lot of people have seen that promise and that desire for kind of a more democratized interface to machine learning, and they're ready to invest the dollars in it. But the kind of tooling and the platforms or whatever else it is that they need to fill that last mile have not caught up yet, because the vast majority of them have not put in an application into production just yet.
And you mentioned LLM applications. It kind of brings up the question that, for example, do you see a future that, we have tons of SaaS applications now that essentially for everything you wanted to do, there are some SaaS applications you can go and just automate or manage that process and collect data. Do you see a future that, for example, there will be zillions of, LLM applications that people can really offer, their own kind of maybe data model or maybe their own kind of LLM, and they say, hey, this is really what can serve this particular purpose and you can use this. Is it what you see coming very soon?
Yes, that's the future that I see like happening over the next 24 months. And really, I think what I think about with that is, and by the way, the reason I say 24 months, which in my mind is actually a fast time frame, is like we had ChatGPT come out end of last year, and the kind of level of progression since has been unbelievable, much faster than I would have expected. And so I really think it will be coming soon. But I think that the future is not going to look like a single large model like ChatGPT, dominating the SaaS application landscape. I think it's going to look like many, many task-specific, fine-tuned models that are each good at doing their own individual thing. One of my favorite customer quotes is, generalized intelligence is great, but I don't need my point of sale system to recite French poetry. And so I don't think we're going to have, these individual single models that that dominate as much as we will have individual SaaS applications building and fine-tuning small LLMs that are task specific. And I think that's what the future is going to look like.
And I wonder, based on what just you said, Dev, if you see the future would be about these LLM applications replacing SaaS applications or just maybe enhancing those and being added as a kind of some feature set to existing apps.
Definitely. I strongly think that this is true every time that there's a large secular shift in technology, which is that there's going to be three types of organizations. There's going to be the incumbents that integrate that new technology and build a better workflow. There's going to be new players that basically replace an existing incumbent because this technology is now their competitive advantage and they're able to operationalize it faster or they're AI native. And then finally, I think that there are going to be new types of companies that we didn't even think about existing like a number of years ago. So if you take, for example, the rise of like data warehousing and data analytics, I think that you saw something very similar, which was there are some companies like a Capital One, existed far before Snowflake, but was able to be able to integrate that as an incumbent and bring it into their core offering and make themselves a lot more competitive as a result. I think then you see companies that start off as just data warehouse native, data analytics native, and they're able to supersede other companies. They're just more competitive because they have this as part of their DNA. And I think we'll see the same kind of bifurcation with the LLMs, which is, I think Adobe and Photoshop have done a great job, or Notion have done a great job of integrating in LLMs into their offering. But you also see new players like something like a Runway ML in like Visual Studio editing that will probably replace a large part of what was traditional video editing. And then finally, I think you'll have a new class of products and technologies that are just unlike anything we've seen before because their underlying capabilities were not possible. And so I think that's what the future is going to break down into these three herds. And it's important to note that folks that do not integrate these technologies over a 5-year time period will probably no longer be competitive.
Interesting. Thank you very much for the perspective. Now, I would like to go back to your company, actually, Predibase. First of all, just wanted to ask if the name, it comes from predictive part that is Predibase, or there's a different base for the name, pun intended.
And it does come from the predictive part. Predibase as a name really comes from this idea that every organization should be able to learn from kind of the 70s revolution in database technology. You know, in the 70s, databases were like these massive behemoths that you needed specialized COBOL developers to be able to use and operationalize. And Predibase, I think, is the idea that, like, you know, databases now today are almost like something that any developer can pick up and integrate into the applications. And we want to do the same thing with a predictive database. And so that's where the name Predibase really came from.
So on the Predibase, the kind of website, when I went there, and it was fascinating the way you explain it. And it seems to me that essentially the way it works, people can come in and use your technology that helps them to save time and do what they used to do with other products now much faster. Is it about that? Or do you think it's more to it? It's not like you do it faster because we are low-code AI and, you know, LLM kind of application builder in a low-code style, but we are also doing things and offering things that you couldn't do before. It's not just we do it faster. There are some caveats there, and we offer something very special.
Yeah, I mean, I think the key thing that we offer is we accelerate the time to value, so make it faster, but we also lower the barrier to entry for developers and engineers who want to be able to build production deep learning models. And so the key thing that I think Predibase allows an engineering team to be able to do is start to build and work with models on top of unstructured data inside of, you know, weeks instead of months overall. And so we see, like, our users and organizations be able to build software that does things like receipt scanning or content moderation, personalized recommender systems, not just a lot faster, but also without requiring the user who's kind of got the PhD in machine learning and, you know, the infrastructure team that has been able to stitch together many different tools. We provide a lot of those abstractions and infrastructure out of the box. And so I think it's really around accelerating the time to value and lowering the barrier to entry for what our goals
are. Yeah, fantastic. So now with these tools in the market, when someone come in and just using these technologies and building their kind of, you know, application, how do you see the deployment of these can work? On the development side, now you are helping people to develop. How do you see the deployment side can work?
It's a really good question, because fundamentally machine learning has, you know, two main challenges, I would say, in my mind. The first is, like, how do you train your model and get to the point where things are good enough where you're ready to actually reap value from it? And then the second is, how do you think about actually putting that model into production or deploying that model, which means not just serving it, but also having the post-deployment monitoring and everything that goes along with it. For us, you know, we obviously start providing the value on the training side, but to have an end-to-end story, it's important that we're able to do something on deployment as well. And so the way we've actually architected our system is to be able to support two different types of deployments. The first is for batch prediction, and the second is for real time. Now, when customers come to us for batch prediction, they're basically trying to use Predibase as a pipeline. They want to read data from an upstream data source like Snowflake, which might be an entire table. Maybe they have hundreds of thousands of rows like customers, and they want to run those predictions every hour, every day, or on some time interval. We in Predibase provide like an orchestration layer where you can essentially just schedule these batch jobs to run anytime that you want. And so in that case, what we're really optimizing for is throughput. We want large number of data points to be able to be processed by our models every time interval. The second type of deployment we support is real-time applications. And with real-time applications, we try and make it as easy for developers as possible. So we spin up the model and we handle the infrastructure for serving that model, and then provide developers a single API REST endpoint that they can use. And they just integrate it into their applications by being able to call it by REST from any downstream source that they might be interested in. And so, deployment ends up being a large challenge for many organizations. And we still have even more work that we want to do here in terms of how you can monitor deployments and others. But for now, we've tried to build the solutions that we see as being necessary for both the batch as well as the real-time use cases.
Um, Whenever there is a new wave coming, like for example, there was cloud concept, then you see the birth of AWS is coming and becomes the new operating system, right? So before this AWS existed, people were talking about, hey, should I use should I use .NET platform or Java platform for my application? But then afterwards, it's more, should I use AWS or should I use GCP or should I use Azure? So as you see, the platforms are totally changing. Now you see the birth of these kind of LLM and AI and those kind of things. Do you think the players as the platform providers are going to again change, or are you going, or you feel like not all of these cloud providers at the moment are the same? So they may stay, but the order may change based on who's more savvy and who's ahead of others with regarding to these new technologies. How do you see that kind of shift happening?
Yeah, I think that ultimately there's going to be some newer players in the space to join these platform like providers, like the cloud providers and other vendors overall. And the way that I see that kind of playing out is today you have the hyperscalers, Google Cloud, Amazon, Azure, that really dominate the infrastructure market that technology is built on. And that means every company from something like Capital One to your tech startup like us. And I think the way that that's going to shift is that I think that this LLM and AI capability is going to be as important for a large number of organizations as cloud has been. And you're going to see AI infrastructure companies be just as dominant as the cloud providers in being able to provide that. And that's going to break down in two ways in my mind. There's going to be these proprietary commercial large language model companies that basically sell specialized infrastructure just to be able to run inference on their models. So think about OpenAI or Cohere or Anthropic, which is going to be proprietary models that are owned, in kind of a walled garden approach. And the second type of platform infrastructure company I think you're going to see is going to be the company that allows you to build your own models and customize and tweak. And they'll host the compute and the abstractions and the models for you to be able to actually customize and build your own. And that's the space Predibase is going to operate in. Ultimately, though, if you look at a company like Google, for example, and you look at how their compute spend breaks down, Google spends an incredible amount of money each year. I believe it's like something north of 30 or 40% on AI infrastructure of their overall data center spend. And I think that's going to start to mirror other technology companies and other companies broadly as well. And so this is going to be as important for them as any of the large cloud hyperscalers are today.
Interesting. Very good insight. You mentioned fine tuning, and also you showed us the message on your t-shirt about the fine tuning as the key. And it has been the key about really bringing down the easiness, the quickness, and the cost of really training data. And it has been one of the reasons that now we see that we can really build so many different models so quickly and better, because we are getting better and better at fine tuning. So with that aspect, that really, it's not super inexpensive process for someone to get it and say, let me just build my kind of, model and go forward. And it's not still that cheap. It's still, you need a lot of money if you want to. And if you make a mistake, probably it costs you a lot of money and you have to start over. And then for some months you spend. So from your perspective, what is the change that is happening? Is it going to be much, much better? You already have seen probably some improvements, as you mentioned. The progress that you have seen is faster than you expected. Does it relate also to the fine tuning of, process that, we are experiencing?
Definitely. I think it definitely relates to that. And, we, again, like to say that the future is fine tuned. I think the biggest thing that's going to change is people will stop trying to use a cannon when they really need a scalpel. for like a given, type of surgery. And so I think what's going to change is that the cost of these of fine tuning is going to go dramatically down, and you're going to see a much more iterative process to actually do that. So let me just give you like a little bit of data on why I believe that. When we ask again in this 150 execs, data scientists, and developer survey, how users want to be able to customize their LLMs, fine tuning is by far the most common customization technique that users want in order to be able to bring in their data to the models. But even though that they say that fine tuning is the thing that they're most interested in, 67% of the users have not fine tuned. And two of the most common reasons for why they haven't is because they view that it's too complex and they don't know how, or they think it's cost prohibitive. The truth is, we actually have spent a lot of time and effort on our side to get the cost of fine tuning down. Right now, you could go into the Predibase platform and get on our free trial and fine tune Llama 2 7 billion, for example, for free. I'm putting out a blog post shortly about how we fine tuned a code generation model for less than the cost of a sandwich in San Francisco. And so how do we actually get these, things to be able to do fine tuning instead of being, what you've seen with pre-training, which was hundreds of thousands to millions of dollars. Fine tuning jobs used to be thought of as tens of thousands and, more expensive per model. We're really talking about being able to get each fine tuning job down to the level of just dollars.
Wow.
And the way that we've really done that has been two predominant ways. The first is knowing which model to use for your task, not needing to be able to, again, use the cannon when you need a scalpel. So you can fine tune a smaller model, which will automatically make things an order of magnitude cheaper. And the second have been things that we've done on both the hardware and software side to make it so that you can fine tune on really commoditized single GPUs. So rather than having to pay for a really expensive large number of racks, we use approaches like parameter efficient fine tuning and quantization to be able to really lower the kind of cost required for it and get it to the point where, again, I can fine tune on Code.vaca for $5, which is a lot less than I spend on lunch. And so that's, I think, the way that we would probably see the future actually going into this direction is making it a lot easier and also a lot cheaper.
That's fantastic because, I read a report about a year ago that I think came from Stanford that was talking about how AI can be really even, from environmental perspective, a problem if we cannot solve that issue that, we are using too much probably power and all of those not, running the models and making everything more efficient from fine-tuning perspective, training the model, using the model, it will help to really move that forward because otherwise the consumption of the energy that today you need in order to drive that, it can be something that if we go with very, very large scale, everyone on earth, the same way we use our smartphone and SaaS, we wanted to at that scale use AI, then we need to be able to be way more energy efficient in order to do that.
Yes. And I think for us, this is one of the things that we probably actually feel most passionately about as an organization is being able to, work when you don't have racks and racks of GPUs because most companies both can't afford or access that many sets. And so we want to be able to get these models working. And a lot of what we support today is things working on a single GPU, one single node that can cost as little as under $1 an hour. And so that's really kind of our goal and orientation. And ultimately, we hope that the way that the data centers will then be orchestrated around this too will make it to be a lot more environmentally friendly.
Fantastic. It has been a great discussion and I really appreciate your insight, Dev. I'm going to ask you also if you could share a book that you like with the audience. And it can be any book that you would like in your professional life or something that you personally liked it.
Yeah, definitely. I would say a book that I really like, and it's both personal and professional actually, is called The Happiness Advantage by Sean Aker. He's a Harvard professor in behavioral psychology, and he more or less talks about two things. The first is how just personal happiness is correlated with professional success, and why therefore it's incumbent on executives and organizations to be able to invest in that and be able to get higher performance, and how much happiness is kind of in our control. and ways that you can kind of take that into your own hands on a day-to-day basis. So I think it's a really well-studied empirical book that talks about things, both on a theoretical level, but grounds them in specific case studies. And it's useful because if it makes you more productive, it's great. But at the end of the day, like if it makes you happier, like that's just the end goal. So that's probably one of the key books that I really liked.
Fantastic. Thank you very much for your time. And we wish you all the best.
Thank you very much, Armand. Thanks for having us.